Okay, looking at 8.4, logarithmic and exponential equations. When solving a logarithmic equation algebraically, start by applying the laws of logs to express one side or both sides of the equation as a single logarithm. Okay, some useful properties of this. So if I have log C of L and is equal to log C of R, well, log C is the same thing on both sides, so that must mean that L is equal to R. The equation log CL is equal to R can be rewritten with logarithms on both sides of the equation as log C of L is equal to log base C to the R. Okay, so just a little something we might use. The equation of log C L equals R can be rewritten in exponential form. Okay, so C is our base, R is our exponent, and that's equal to L. The logarithm of 0 or a negative number is undefined. To identify whether a root is extraneous, substitute the root into the original equation and check whether all of the logarithms are defined. In other words, we don't have 0 or a negative. You can solve an exponential equation algebraically by taking logarithms of both sides of the equation. Again, if L is equal to R, then log CL is equal to log CR. Then apply the power of logarithms to solve for an unknown. Okay, so we'll take a look here at some examples. So example 1, solve, give exact answers. Well, this is just simply converting from a log to an exponential. So my base is 4, my exponent is 5, and that is equal to x. 4 to the power of 5, 1024 is equal to x. So these can be just as simple as that. Okay. B, I'm going to apply a logarithm law to this. This 2 out in front, if we think back to 3.4, it could be rewritten as the exponent on my x. So this could actually be log 2 of x squared is equal to 10. Okay, now I'm going to use this rule, that same thing I used over here. I've got a base of 2, got an exponent of 10 is equal to x squared. 2 to the 10 gives me 1024 is equal to x squared. And then I take the square root of both sides and I end up with 32 being x. Okay, keep looking at some examples similar to these. Log base 6 of x plus 3 plus 2 equals 5. Well, let's move this 2 over. Log base 6 of x plus 3 is equal to, I subtract 2 from both sides, so I get 3. So now I'm going to get 6 to the power of 3 is equal to x plus 3. Well, 6 to the power of 3 gives me 213 equals x plus 3 minus 3 from both sides. And I get 210 is equal to x. Okay, very similar here. We've got this 2 out in front. Well, let's try dividing both sides by 2 to get rid of it. So I get log x minus 5 is equal to 6 divided by 2 is 3. I know that this is a base 10. There's no base written there, so it must be a 10. So 10 to the 3 is equal to x minus 5. 10 to the 3 is 1,000 equals x minus 5. And so finally I get that 900, oh sorry, or add 5 to both sides. So I get 1,005 is equal to x. Okay, so some pretty simple examples on the front there. We're asked on these ones to solve, give your answer to 2 decimal places. So here I have 12 to the power of 3x is equal to 1,000. Okay, what I'm going to do is I'm going to take the log of both sides. Okay, so I'm going to go log of 12 to the 3x is equal to log to the 1,000. Now, if I don't write any base with it, we have a base 10 here. Okay, thinking about some logarithmic laws, I'm going to move this 3x out in front. So I get 3x log 12 is equal to log 1,000. Could divide both sides by log 12, and I could get 3x is equal to log of 1,000. over log of 12, and then I would want to divide my answer on both sides by 3 so that I get x is equal to, so I'm going to say I'm dividing that by 3. We're also going to divide this side by 3. So in my calculator, and depending on what you're using, I'll take a look at my iPhone here. Okay, there's a log base 10 button right there. So if I go 1000 log base 10 divided by 12 log base 10 equals, and I'm going to divide that number by 3, and if I'm answering to the nearest tenth, I get 0.93. Okay, skip down to C here, take a look at this example. Again, I'm going to take the log of both sides. When my x is in the exponent, I don't know how to get it out of there, I don't know how to answer it, besides taking the log of both sides. So log 3 to the power of 2x over 3 is equal to log 350. This 2x minus 3 can be brought down, or 2x over 3 can be brought down in front. Similar to the question above, we can now divide both sides by log 3. So again, my goal here is to get x by itself. Okay, so I'm going to divide by log 3 on both sides, and then I want to get x by itself, so I'm going to divide by 2 over 3, which is the same as multiplying by 3 over 2. So I get log of 350 over log of 3 times, again, times it by the reciprocal, 3 over 2. And so I'm going to find out here that x equals, think about 8.00. Okay, I'll post B as well, but we'll just, for time's sake, keep moving along here. So in example 3 here, again, we're trying to find what x is, but right now it's written as an exponent. Okay, I'm going to do exactly what we did here, but I'm just going to skip a step, and I'm going to say, okay, I know that this exponent's going to come out front, and then I'm going to have log of 5. And same over here, this exponent's going to come out, and I'm going to have log of 10. Okay. Now, this is actually all multiplied by that. So I'm going to distribute this, and I'm going to say, okay, I get an x log 5 minus a 3 log 5 is equal to an x log 10. Okay, I'm going to regroup so that I have my ones with a coefficient of x together. So I'm going to subtract this over here and add that over there. So I end up with x log 5 minus x log 10 is equal to, and I'm moving this over here, 3 log 5. Now what I can do here is I can factor out an x. So if I factor out an x, I get x times log 5. I'm taking out an x here, so I'm ending up with log 10 is equal to 3 log 5. Divide both sides by log 5 minus log 10. I get x is equal to 3 log 5 over log 5 minus log 10. Okay, and so again, if we take a look at that in a calculator, so I should have 3 times, and then it should be 5 log equals, so that's my numerator, 2.0969 blah 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 blah, and I'm going to divide that by, I'm going to put a bracket under here, and I'm going to go 5 log minus 10 log bracket equals, and I get about negative, oh, you can't see that on the page here, there we go, I get about a negative 6.97. Okay, so I took the log of both sides to move those x's down so they weren't out in front anymore. Okay, I'll post the solution for B as well so you can see what we did there. Just take a look at the back, a couple more examples. I'm going to use the exponent laws that we talked about now in 8.3. So I have a log of base 2 to this minus log of base 2 to that. So when I'm thinking about my exponent laws, I know that this subtraction, and if I have the same base, I can rewrite that as a division. So 4x plus 10 over x is equal to 3. Okay? And now that I'm at this step, well, I know that 2 to the exponent 3 is going to give me 4x plus 10 over x. Okay? I'm going to do two steps here. One of them is I'm going to rewrite this as 8, and another is I'm going to multiply both sides by x to get rid of this. So 8x is equal to 4x plus 10. I'm trying to isolate x, so let's subtract 4x from both sides. I get 4x is equal to 10, and then I get x is equal to 10 divided by 4, which is like 5 over 2. Okay, same thing in b here. I can think about my exponent laws. I have the same base, and I'm subtracting, so these are like dividing, so x plus 7 over x minus 3 is equal to 2. Once I have it written as a single log, well, now it's 3 to the power of 2 is equal to x plus 7 over x minus 3. Again, do two steps at once here. I'm going to make this into a 9, multiply both sides by x minus 3, distribute my 9, and then I'm just going to solve for my x. So I'm going to move this x over here. I'm going to add 27 to both sides, and then divide both sides by by 8, and I'm going to end up with 34 over 8, which is like 17 over 4. Okay, just one more look at another way we could do this, or another way we could look at these examples. Here I've got addition, which I know is like multiplication when I combine them. So I have log base 6 of x. And actually what I could do is I could move that 3 up there right away as well. Is equal to, this is like log base 6 of 9 times 24. So since we have the same base, I can say that these two things are equal. X cubed is equal to, and 9 times 24 gives us 216. If I take the cube root of both sides, I'm going to find that x is equal to 6. Okay, same thing here. We're adding, so I can change this to a multiplication question. X times 4 equals log base 7 of 12, so 4x equals 12, and x equals 3. Okay, you got an assignment at the bottom of the page here, page 412, numbers 1 to 5, and 7 to 8.